Welcome, guys. We got a little warm up dealing with bearings. So pause the video, try this one out. Let me move this out of your way so you can read it. Draw the example, solve it out, and then when you're ready, hit play. All right, here is your final answer for this warm up problem. Keep in mind, drawing that picture, you are modeling the path of a plane. So in black, I've drawn the path as it goes from Niagara to Cayuga and Cayuga to Rosemont. The bearing to return is the tricky part that I did in blue. I have found the angle at Rosemont, added 8 because I want the bearing to return, which would include that 8 from the alternate exterior angles. South 45.7 degrees west. All right, you can pause if you want. Here are the homework answers. We're going to fly through. All right, and today what we're going to do is we're going to practice applications of oblique triangles, specifically talking about area. So we know law sines and law cosines already. We're adding 2 new formulas to our arsenal. Keep in mind when we name oblique triangles, we have capital letters ABC for angles, lowercase letters ABC for their corresponding sides. So these 2 new formulas are going to use that notation. And here it is. Area formula number 1 is the side angle side area formula. Notice there's 3 setups. Don't write all of them down. Just write this third one down. The area is 1/2 AB sine Cs. And Heron's formula is this. Take a minute to jot it down, then I'll explain what we do with it. All right, we have these 2 formulas. Keep in mind, again, this is the formula we want to use for the SAS area formula, side angle side, which means you're using 2 sides and the angle between it, versus Heron's formula, which uses all 3 sides, finding the semi-perimeter, and using that given equation with the radical. Let us apply one at a time. So the SAS area formula here, number 1. In this diagram, I could technically use either equation, Heron's or the SAS area formula, but as I said, this is the one I want to focus on, and I can use this here because I know I have 2 sides and the angle between it. The angle between it is 49 degrees. The 2 sides that make that 49 degrees are 5 and 7, meaning 5.3 I do not need. The area formula is 1/2 5 times 7 times sine of 49 degrees. So this says lowercase a, lowercase b, but really it's the 2 sides that make the angle. So type it in and see what you get. They can wait. Watch a little bit. Love it. It is an area, so it's units squared 13.207. That is the SAS area point. All right, that's the first formula. Second formula is Heron's. It looks a little bit hairier, but it's really not that bad. So take a moment, jot down this triangle. Side lengths of 5, 7, and 9 makes it pretty clearly a side-side-side triangle. So side lengths of 5, 7, and 9. It doesn't really matter if you label the angles or not, because what's important is you know all 3 sides. So your first part you're going to do is just find the semi-perimeter, which is 5 plus 7 plus 9 divided by 2. So the semi-perimeter is 10.5. Be careful how you type that in your calculator. If you're doing that all in one line, make sure you put parentheses around that 5 plus 7 plus 9. Once you have semi-perimeter, you can use your whole formula. So the area is equal to the square root of, it's the semi-perimeter, 10.5, times the difference between the semi-perimeter and each of your sides. Doesn't matter what order you go, so I'll do 10.5 minus 5 10.5 minus 7. 10.5 minus. We'll give you a minute because that's a bit of a line to type in. Type it in, see what you get. All right, guys. Answer from Heron's formula there, side to side. 17.412 when you use your calculator skills correctly. All right, I got a minute for you to try them out. So again, pause the video and see what you get with these two. Resume when you. All right, we got our answers up for this. So first one's best to use law of side angle side because you have two sides and the angle between it. 56 is your distractor. Don't use it. In B, you could do SAS area formula, but you first have to find an angle with law of cosines. That's requiring a lot more work. Why not just use Heron's formula? Boom, right there. All right. We're going to do a couple quick applications and call it a day. We'll just walk through these guys together. So, here we go. Carter. Oh my God. Wants to see this triangular yard picture below. If one bag of grass seed covers 2,800 square feet, how many bags should he buy? So there's a nice depiction of Carter confused at his yard. It's triangular. I see these two streets and the angle between them. That is two sides and the angle between it, so I can find the area really quickly with our SAS area formula. 1/2 110 times 126 times sine of 74. Let's find that area really quick. I trust you. So a little over 6,000 square feet. If you don't go to Home Depot and just tell the guy, like, hey, my yard's this big, you gotta do the math yourself. Really testing today. I appreciate you being honest. What do I do with that number? Divide it by how much each one is going to cover. So 2,800 is what I divide it by, and I get 2.379 bags. Would you go into Home Depot and say I need 2.379 bags? No way. You got to round up. You'll have a little extra for next year. 3 bags. All right. Bags of seed. Bags of seeds. All right. One more application. Check out this adorable dog. That's my boy Dodger. That's my actual dog. True. Show and tell team's called. This is my show and tell. The intention of show and tell is the most important part. All right, so I'm building a triangular sandbox for my dog Dodger to play in. The sides of the sandbox are 9, 12, and 16. It's a triangle. 9, 12, 16. I want to figure out how much sand, you guys love to dig in sand, how much sand I'm going to need. So I'm using area because similar to the previous one where you're seeding the whole yard, you want the area to fill in the whole yard. Here I'm trying to fill in this whole triangular sandbox, sand triangle, I guess. So because we have all 3 sides, we can do this Heron's formula. First, find the semi-perimeter. 9 plus 12 plus 16 and divide it by 2. 37 divided by 2 is going to get you 18.5. Once you have your semi-perimeter, use it to find your area. All right, you get an area of about 53, 3.441. And again, each bag covers 5 square feet. I have 53 to cover, divide by 5. It gets me 10 and change, but what do? Bump up to 11 bags. Gonna have a little extra, that's fine. He's gonna end up digging and eating some of it. Cool. All right. He's 4.5.